So there's this lab we would do where we have 3 beakers, one with just water in it, one with damp sand, and one with dry sand. And these things are under a heating lamp, and so an infrared heating lamp. And we would turn it on and watch the temperatures change for some amount of time. I don't know, like 5 minutes, 10 minutes, something like that. And what we would find is that I'll go ahead and tell you what we find. The dry sand heats up very much so. The damp sand, meh, and the water, not nearly as much. But this dry sand, it really takes off. It heats up a lot. So what this is representing is that water has what we call a high heat capacity, meaning it can take in energy and hold on to it. It's slow to release that energy, as opposed to dry sand, which actually takes in the energy very easily, but it also loses that energy very easily. So the point being that the temperature of the sand heats up and cools down very quickly. Like if you've ever been to a beach on a really hot day, on a bright sunny day, and you've had like an umbrella, like a sun umbrella, then the sand under the umbrella, the sand in the shade, perfectly cool and fine. Then you step out onto the regular sand and it burns your feet. That is because of that poor heating capacity of something like sand. Where the water basically maintains its temperature throughout the whole day and doesn't even change that much at night. Well, what this has to do with climate controls, so land, sand especially, but other land as well, heats and cools a lot faster than water. So here's what this has to do with climate controls and on Earth. If we have a city over here in California, this is going to have a very mild temperature range because it's next to the Pacific Ocean with the air circulation going this way. Because the temperature of the water doesn't change all that much throughout the entire year, then the air above it doesn't heat up as much. And so the temperatures coming in are pretty much, a fairly small window of a temperature range here. So this is a moderate annual temperature range. Whereas then there's places like Noblesville, Indiana, where our air coming in a year is from over land, and this land surface heats up a lot in the daytime and cools off in the nighttime, or it heats up a lot in the summer and it's very cold in the winter. So that affects the air on top of it, which then blows into Indiana. So we have extremely cold days in winter and extremely hot days in summer. We have a much wider temperature range. Notice this temperature range is wider and this one is smaller. Now, one more thing about this I want to point out is there's an extra credit question on the quiz where I ask you to address why I put foil down here under the heat lamp and under these materials. I want you to think about the albedo of the foil. You may have to look back at your albedo notes to remember what that means and why would I choose foil. And I will tell you a funny little story. The first year I was teaching this particular lab, I melted a tabletop surface. You can actually return to that old classroom and see the melted surface on that permanent lab table. Anyway, quite embarrassing. But so since then, I have covered it in foil, and I want you to answer, why did I do that? Now, some other temperature controls, if you care to know, if you just want what you need to know to get the grade, then stop watching now and move on with your life. Other temperature control, so climate control factors. Something that is at a high altitude will be cooler, lower altitude area will be warmer. That is only true of the bottom layer of Earth's atmosphere, which includes up to Mount Everest. So even the highest peak a human might be standing on is still subject to this rule, whereby higher up is colder, lower down is warmer. Latitude is also a climate factor because closer to the equator, it is warmer because there is more sunshine, and throughout a year farther from the equator, colder. Cloud cover is a thing because clouds have a high albedo. They reflect a lot of light. During the day, it would be cooler than if it were a perfectly clear day, because in a perfectly clear day, the sun comes and absorbs at the land, it heats up. On the cloudy day, that sunlight is reflected back out to space. The opposite is true at night. On a cloudy night, it will be warmer because the heat is coming from the land, and that heat radiates off the land, hits the clouds, and bounces back down because of the albedo, in other words, in this case, the greenhouse effect of the clouds. On a cloudless night, that heat from the surface completely goes out to outer space. Now, it will occasionally hit like a greenhouse gas here in our atmosphere, but most of it is going to go out. So, note to those of you who want to try and go like watch the stars or something on a clear night, bring warm things to wear. If it is a good night for viewing the outer space nighttime sky, it will be cold, even if it's the middle of the summer.